Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your book from Chapter 9, Section 1. Now, here's what's going to happen in Section 1. We are starting a chapter, Chapter 9, which is on conic sections. But before we jump into those conic sections, and we'll look at 4 different types of conic sections, I just want to review a couple of things with you guys that are very, very easy concepts you would have looked at back in Algebra 1 and Geometry, the distance and midpoint formula. And here's the reason why. I am not necessarily, if you're taking this class with me, I'm not necessarily going to ask you on a test or a quiz, how do you find the midpoint between these 2 points? Or how do you find the distance between these 2 points? How do you find how long this particular line is, right? That's really kind of stuff we did in geometry, and we won't really use that here other than this. The reason I'm going to review distance and midpoint formula with you is because when we get to those conic sections, for example, circles, one of the things that they may do is they may give you 2 points on the outer edge of a circle, all right, and tell you that those 2 points are at the ends of the diameter. And then they'll ask you for the equation of the circle. Well, in order to find the equation of a circle, you need to know where the center is. So you would have to be able to find the midpoint of the diameter. Then once you know the midpoint of the diameter, another thing you need to know in order to write the equation of a circle is you need to know the radius. Of course, the radius would be half the diameter. So you can use the distance formula to find the length of the diameter, divide it by 2, and you've got your radius. So the only reason that I'm going to review with you here in Chapter 9, Section 1, the midpoint and distance formulas from geometry is because we're going to use them to help us solve problems later. And it's nice to just kind of refresh these things together. So, a couple of objectives for you, or learning targets, as we kind of jump into what should be pretty easy set of notes. You need to be able to find the midpoint of a segment on a coordinate plane. So we'll start with the midpoint. You can see I got it right here. And then we'll go and move on to the distance formula, finding the distance between 2 points, again, on a coordinate plane. So we won't waste any more time. Here we go right into it. Hopefully you'll recall that the midpoint from geometry is just simply this guy right here. This is our midpoint formula. And now's a good time to point out as well. If you are taking this class with me, I have provided you with a formula sheet. It is 1 full page, front and back. It has everything on it you need to know about all 4 types of conic sections, including the midpoint and the distance formula, which I've also put on that formula sheet. If you're taking this class with another teacher, I have yet to meet a math teacher, an Algebra 2 teacher, who makes their students memorize all of the formulas we're going to look at in this chapter. I've yet to meet one. However, some Algebra 2 teachers may want you to remember the midpoint and the distance formula, just because that's something you had experience with back in geometry, and it's kind of like the quadratic formula, or remembering how to FOIL or something like that. It's just one of those things that maybe you should know how to do. But if you're taking this with me, I'll give you the midpoint and the distance formula. That way we avoid you making a simple mistake because you subtract instead of add or something like that. So anyway, here we go. Let's just jump right into it. Remember the way that the midpoint works. What's going to happen is on a coordinate plane, you will be given 2 endpoints. In this diagram, the point P and the point Q. We'll call one point x1, y1, and the other point x2, y2. And I make this little note. It does not matter, right? As far as the math goes, it does not matter which point is x1, y1, and x2, y2. It doesn't matter, right? You could do x1, y1 one point, x2, y2 the other point, and the person sitting right next to you could switch them and make this one x2, y2, and this one x1, y1, and you're going to get this, as long as you do the algebra right, do the math right, you're going to get the same answer. So it doesn't matter. But I do make this little note here, just for me. I like to make the point farthest to the left x1, y1. So as I go down through these problems, you'll just see me picking x1, y1, and if you're wondering, why is he making that one x1, y1? It's for this reason. Whatever point is farthest to the left, I'll make x1, y1. And the hope is this, when we do eventually get to subtracting, it just hopefully will make the numbers maybe come out a little bit nicer. It doesn't always work, but anyway, farthest to the left, is what I'll generally make x1, y1. So then the way the midpoint works is you're looking for the point that is exactly halfway between P and Q. And the way that we find it is given to us by the midpoint formula. So I got a couple of example problems for us here. Let's just go ahead and jump right into these. All right. Up first, I need to, given 2 points, I'm asked to find the midpoint, so I need to label the points x1, y1, x2, y2, and remember, whichever one's farthest to the left is the one I'll make x1, y1. So, -1 and 6. Well, -1 is farthest to the left, so this will be my x1, y1, this will be my x2, y2, and remember the midpoint formula is x1 plus x2 divided by 2. That will give me the x coordinate. This will come out to be the x coordinate, comma, y1 plus y2 divided by 2 is going to give me the y coordinate. Now all that you need to do is just simply plug that stuff in. So here we go. I'm going to have a -1 plus 6 divided by 2, and I'm going to have a 2 plus 1 divided by, not 3, divided by 2. And what we get, well, -1 plus 6 is going to be 5, so that's going to be 5 halves. And 2 plus 1 would be 3, so that's going to come out to be 3 halves. So the midpoint between these two ordered pairs on a coordinate plane, the midpoint is 5 halves, comma 3 halves. If you would rather write that as decimals, which generally I will, because we will be doing quite a bit of graphing in this chapter, and it's easier to graph decimals, which of course would be 2.5. 5 halves is 2.5, and 3 halves is 1.5. So I would simply plot a point, 2.5 on the x-axis, 1.5 on the y-axis, and I've got my midpoint. Let's try a couple more. All right, once again, I am given 2 ordered pairs. So first I need to figure out x1, y1, x2, y2. Again, it doesn't matter which one you label which way. But like I said, I do like to make the one farthest to the left x1, y1. So this one will be x2, y2. And we'll just start plugging stuff in. All right, so remember my formula is x1 plus x2, all divided by 2. And then y1 plus y2, all divided by 2. We'll plug in what we know. My x1 is a -4 plus 5 divided by 2. And then I have 8 plus 12 divided by 2. We wind up with, looks like I get 1/2. And 8 plus 12 is 20. 20 divided by 2 is going to be 10. So if you wanted to as a decimal, of course, 0.5. So you go half a unit on the x-axis, go to 10 on the y-axis, and you found the midpoint exactly halfway between these 2 points on a coordinate plane. I got one last one for you here. Again, I know, easy stuff. You'll remember midpoint from geometry. We're just reviewing it together, so when we see it later on, we will already have looked at how it works, and it'll help us solve some conic section problems later on. Again, I need to go ahead and label these guys. It does, in fact, you know what, let me show you. I generally would make this one x1, y1 because it's farthest to the left, and this one x2, y2. So if you want to do that, x1, y1, x2, y2, solve yours. I'm going to switch it, show you we get the exact same answer. Okay, so again, it's x1 plus x2 divided by 2. And then it is y1 plus y2 divided by 2. And here we go. I'm going to have 14 plus 4 over 2. And I am going to have 13 plus 5 over 2. Which comes out to be, 14 plus 4 is going to be 18 halves. And 13 and 5 is going to be, what, 18? Oh, look at that. Yeah, 18 halves again. So what we wind up with is a midpoint that is equal to, of course, 18 divided by 2 is 9. So exactly halfway. The midpoint between these 2 points is 9, 9. And if you had done it, x1, y1 farthest to the left, x2, y2 point farther to the right, you still would have wound up with 9, 9. All right, guys, that's just a real quick review of the way the midpoint formula works. And again, remember, the way we're going to use the midpoint formula later on is with conic sections, when maybe you're having to find the center of a circle or an ellipse using the midpoint, or find the radius of a circle by using the distance formula and dividing it by 2. Anyway, it'll show up later on in other problems. Head on over to the next page of notes. We'll take a look at that second objective, which is the distance formula, and I'll meet you guys there.